Hey guys, as I promised in my last video opening up some packages, I wanted to show opening up this step-down converter and testing it. Now I've purchased it originally so that I can place it in my power supply. I've made this power supply for myself out of an old PC power supply. But it only gives fixed voltages, 3.3, 5 and 12, and there's also a 25 volt line, but that's on the standby. And with this one I thought of just mounting it inside the box and replacing these two pots with bigger ones that will sit on the outside. And then I can vary the voltage. I can connect the 25 volt line here on the input and get any voltage output that I want. So I'm gonna test it here with you real quick, just to see how it works. I don't have any professional measuring equipment, nothing like Big Live or EEV, but just with my basic things here and just showing you how it works and how it does it. You get a small heatsink with it. Never saw a heatsink with double-sided tape here. Would probably melt off if it goes hot, but in any case I have here, I've set up here a dummy load. This dummy load I just made, it's the version that is shown by Dave Jones on his EV channel. And you can go there, it's episode 102, and he gives you the schematics and everything. Only I didn't have the exact parts, so I used different parts. I used a different MOSFET here in IRLZ, and this spot also, it's 40K, so it won't give the exact things. Also here I use these 1 watt 56 ohm resistors. I should have used 1 ohm, but yeah, just for this demonstration, hopefully it will work. It works, but hopefully it will just do it well. So let's get on it. I need to connect it, so here is the input and the output, and it also has a USB output. So first of all, I just want to connect it with the multimeter here and see how it goes. So I've made this whole setup here, and hopefully it all goes well. But it's a 5 to 36 volt input. It can take 5 to 36 volt, and it will give an output between 1.2 and 32 volts. And it also, as I said, it has a current limiting inside. Well, inside it has current limiting functionality, and it cost me $3.91, which is quite cheap, so I'm happy about it. And it looks quite good. It looks solid. I know you shouldn't judge electronics on the way that they look, but to me it looks okay. And it can provide from 0 to 5 amps, so you can get quite nice, you can operate nice things on it, LEDs and things like that, and it can dissipate 75 watts. So yeah, I'm gonna connect the voltmeter here. I'm trying to make this video as fast as I can. I don't want to drag it like 10 minutes. Usually I say that, but then it gets dragged, and I can't do anything about it. The way I talk and explain things. I don't mind it, but some people get annoyed about long videos. I don't get that, but yeah. So anyway, I got it connected. Let's set it on 20 volts, and there go this away so that we don't short circuit anything. Let's turn it on. All I have is a 12 volt power supply, which is just this transformer here, and it can give 1 amp. So right now I'm getting on the output 10 volts from the 12 volt input that I provided it with. And if I adjust this screw, let's see what happens. Oh, need some sort of a smaller screwdriver here. Hopefully I have one. This one's better. This one doesn't do anything. No. So you can see I can lower the voltage from 12 volts all the way down to 1.25. That's nice. If I press this button, so this shows amps and this shows power dissipation. So right now it has an input of 10.8 and it gives an output of 2.8, which also shows here 2.8. So it's calibrated. There are instructions on how to calibrate this thing, but it's nice. So the next step, since it's working and it's giving the right measurements and everything, I want to connect it. I want to connect it to the load, and I'm going to connect my my multimeter in series with it. So this one receives the output, and here I have the input for my load. I was looking at the package of this. I was looking at that heatsink that came with it, and then I remembered. Yeah, I need to buy a. I need to buy that thermal paste so that I can stick those things on. I'm gonna put the meter in series with the resistor. Let's put it on 200 milliamps, and I also need to connect the ground. So I'm gonna take it from here, and then we can also test the current limiting and see that it all works. And if everything works fine, then as I said, I want to put it in my power supply that I've built. So I've got everything connected. Let's see, nothing shorting. No, this is okay. Let's power it on. So it gives 2.8 volts. Let's set it a bit higher to like maybe 5 volts. 3.8, 4.6. It's about 5.4 volts. And if I crank it up, then you can see that we're getting 10.5 milliamps. So right now we have 135 milliamps. So if I turn this spot down, you can see that we can lower the current draw. And we're going the other way. So we've lowered it until 15. Well, hopefully you can see that. It's not going to short. We don't want to short anything here. There we go. So right now we have 16.2 milliamps. I'm not sure what it's supposed to be showing me right here. Maybe the current draw, or maybe it needs to be calibrated. So it's showing 0 amps. Okay, so there is an LED here. There is a power indicator and something that says full. And this one, I believe, indicates that the current limiting is on. So yeah, that's step it up. Yeah, so the third LED here shows that the current limiting is on, but I think I need to calibrate it because right now it's showing 0.3 milliamps and we get here 127, 25, 28. So there are instructions on how to calibrate it. I'm gonna go about it, but overall it seems nice. It has this nice display. That's why I've bought it, so that I can just place it in the power supply in the box. If you want to see that power supply, as I said, go back. There is a video that I've made about it, and that's it. I'm happy. $3.9, and I have a sort of variable power supply now. Once I mount it in with current limiting. And it can provide up to 5 amps. It can handle up to 5 amps. And that's it. I'm happy. Hope you liked it. Thank you for watching.